Hi students, this is Mr. Yao. Today we are going to continue to learn more about functions and their transformations. We're going to learn two more types. First, square root function. Square root function is the inverse function of our quadratic because quadratic is basically a square function, which again typically looks like this. And as you can see, the square root is kind of reflected over the y equals x, and it's kind of very similar to what we have for y equals x squared. And we actually write it as square root of x. That's the parent function. Now these are the key features again. Whenever you need them in the future, you can refer to them. But we are just going to use the points since that's how we are going to do our transformation. It's almost exactly the same as last lesson. So for square root, we're going to want some nice numbers for the x and y. And since when we square root a positive number, it's going to be it's typically not going to be a nice number like square root of 2. Let's actually start with the result. We want the result to be numbers like 0, 1, 2, and 3. So that means our corresponding x values should have to be 0, 1, 4, and 9, because the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And since we only have like one side of the whole graph, 4 numbers would be enough. So these are the points we are going to use when we get to the tables. The next function is absolute value. F of x equals absolute value of x. It's a checkmark function. And the points we're going to use are -2, -1, 0, 1, and 2. So we have 2, 1, 0, 1, 2 for the y values because the absolute value of -2 is a positive 2, -1 is 1. And these numbers are going to be provided to you during the quiz. So I'm going to actually have these numbers given to you. So now let's have a look at some examples. Oh, before that, the transformation of absolute value and square root is very similar to the vertex form of quadratic. I'm going to write the quadratic on the bottom for you to see. It's a times x minus h, then squared, and a plus k on the end. That is very, very normal. They all look very similar with an a in the front and then h close to the x and the plus k on the end. So that's why the table, they're going to be very similar. So example 1. We're still going to check our three things. First, we check for multiplication, then we check for negative sign. Third, we check for addition or subtraction. Numbers we have, -2, no, not -2, 0, 1, 2, and 3. 0, 1, 4, and 9. Then we're going to get 1, 2, 3 for the y. 1, 2, 3. Since we're dealing with square root. Now, first, let's check. We don't have any multiplication, so no number 1. We do have a negative sign. It is in the front, so it's going to be a vertical flip over the x-axis. In that case, that means we're changing all the y values into negative, so 0, -1, -2, and -3. Step 3, we are going to check for addition and subtraction. So this is addition, but it's inside the square root. So that means it's actually happening before the function. Meaning we're going to add the 2 first before we even do the square root. So it's before the function, which means it's going to be a horizontal change, horizontal shift, and it's a 2. So 2d is a plot sign. Remember, horizontal is always the opposite. So it's actually to the left, and we are going to do subtract 2 since it's opposite. 0 minus 2 is -2, 1 minus 2 is -1, 4 minus 2 is 2, 9 minus 2 is 7. And these are going to be numbers we use to graph. These are the final numbers. So we are going to, and the parent function again is square root of x. So let's graph it. -2, 0. We have -1, -1, and we have 2, -2, and we have 7, -3. So there's my graph. That's example 1. Next, example 2. Same idea. We're still going to start with 0, 1, 4, and 9. 0, 1, 2, and 3 for the y. I'm going to check to see multiplication first, then negative sign second, and plus or minus third. We do have multiplication this time, and the multiplication is actually in the front of 1/3. So that means it's actually after the function. Again, that doesn't mean position-wise. It actually means calculation-wise. We do need to actually do the square root and then do the times 1/3. So that means it's going to be a vertical shrink, since 1/3 is less than 1, by 1/3. So we're going to multiply 1/3 on every y, 0, 1/3, 2/3, and 1. Next, we do not have a negative. Now we do have a plus 3. The plus 3, that is going to be a horizontal shift 3 to the left. Again, horizontal is the opposite, and also because it's under the square root, that means we add the 3 first, then do square root. That's why it's a horizontal change. Since the horizontal is opposite, so we're going to subtract 3. -3, -2, 1, and 6. Lastly, we do still have this -5 on the end. -5, that's going to be the vertical shift 5 down. Because it's a -5, so it's going down. So we're going to subtract 5 on the y, since vertical is always just the same that we see. So -5, 1/3 minus 5 is going to be -14 over 5. 2/3 over 5 is going to be -13 over 5. 1 minus 5 is going to be -4. So now we can actually graph, and again, parent function is square root of x. So now let's graph. And we are going to use these final points to graph. So here's my graph. -3, -5 is right here. Then we have -4, -14 over 5. Then we have -3, -13 over 5. And then we have -4. So my graph is actually going to go like up very little by little. So my graph is going to be like something like that. That's example 2. Next, it's time, well, actually the other way. Oh, it's over 3. I just realized I calculated them wrong. It's not over 5. It's actually over 3. So that makes sense. This would be here and here. And that one is, so yeah, right there. And it's at 1. And the last one is actually at 6. So there's my actual graph. It's going to be like that. It's a curve like that. Okay, there we go. Next, example 3. Now we're going to write the function based on the description. Vertical stretch, so it's got to be a stretch outside the function, so it's a 3 in the front. So it's got to be f of x equals 3, then square root of x. We have shift up by 3. Shift up by 3 is, again, outside the function because it's a vertical shift. So f of x equals 3 square root of x, then plus 3 on the end. Then lastly, we have left 2. That is going to happen on the x, so it's going to be x. Remember, horizontal is opposite, so left is actually a plus. And we still keep everything else. F of x there, and then square root of x. 3 is there, and the plus 3 is on the end. That's example 3. Next, example 4. Vertical shrink. That is going to be a 1/5 in the front again. We still have a square root of x. Then we have a reflection across the x-axis. X-axis here, so is this kind of a reflect. So it's got to be a vertical reflection. That means the negative sign in the front. Everything else stay the same. F of x stayed there. 1/5 square root of x all stay there. Lastly, we have shift up by 5. So f of x equals -1/5 square root of x. Shift up, so it's going to be after we do the square root after the function, plus 5 on the end. That is example 4. Next, example 5. Now we're dealing with absolute value. Let's write down the initial value first. F of x equals the absolute value of x. -2, -1, 0, 1, 2. 2, 1, 0, 1, 2. 1, 2, 3. Check for multiplication, check for negative, and check for addition and subtraction. Start with 1. We do have a 2 right here, and that is outside the absolute value. So that means it's actually after the absolute value. That means it's going to be a vertical stretch by 2. So multiply by 2 on all the y's. 4, 2, 0, 2, 4. Next, we have the negative sign. It's going to be a vertical flip over the x-axis. So I need a negative sign. That's -4, -2, 0, -2, and -4. So that's all the y values. And then we have this -3 right here. It's inside the absolute value. That means it's going to be a horizontal shift 3 to the minus, so 3 to the right. And remember, horizontal is always the opposite, so we are going to add 3. That gives us 1, 2, 3, 4, 5. And lastly, we still have this +2 on the end, +2. That means it's going to be a vertical shift 2 up. So add 2. That's going to give us -2, 0, 2, 2, then 0, then -2. So let's start graphing these points. Again, we're just going to use the very last points, these points. So we got 1, -2. Right here. Then we have 2, 0. Then it's 3, 2. Then it's 4, 0. And then the last one is 5, -2. So there we go. There's our graph. That's example 5. Next, example 6. This is a very similar idea. However, we see this time a negative sign is right in front of the x. So horizontal is always the opposite, which makes it harder to work with than vertical. But there's something very special about absolute value. We have learned at the beginning of this unit when we dealt with even and odd functions. So we are actually going to do, the easier way is to actually do something very similar. So I'm going to rewrite this, meaning I'm going to factor out a -1. And as soon as I take the -1 away from -x, that just becomes an x. And as soon as I take the -1 away from 2, that now becomes a -2. So that's how we are actually going to do this one. We have a 3 in the front, we have a -2 inside, then we have a -3 on the end. So let me write them down. 1, 2, 3. Multiplication, 3 in the front. That's going to be a vertical change. It's a vertical, more specifically, stretch by 3. Then we have this, we don't need to deal with that because this again is the same as 3 times x minus 2, then -3. So the next thing I'm going to work with is the negative sign. There's no negative sign. Lastly, I do have a -2 first. That's where the addition and subtraction comes. I do have a -2, so that is going to be a horizontal shift. And it's 3, no, not 3, it's 2. And it's 2 left because it's a plus. I'm going to actually write down the values. -2, 1, 0, 1, 2. 2, 1, 0, 1, 2. First, multiply by 3. So 6, 2, 0, 2, 6. And for this current step we're on, shift 2 left. So that means I'm going to add 2. So 0, 1, 2, 3, 4. And lastly, we have the -3 on the end, which is going to be a vertical shift. And it's a 3 down. I'm going to -3. 3, -1, -3, -1, 3. So that is everything. Let's now start graphing the last one. 0, 3. We have 1, -1. We have 2, -3. And we have 3, -1. 4, 3. There we go. Now we have everything for example 6. I'm going to talk about the next few examples in a separate video, so this video is not going to be too long. I'm going to talk about how to find the function from the graph in the next video. That's everything for 4.6b, 16b for now. Thank you.